Hi, good morning, good afternoon. So, thanks for your time today. The reminder for the day is please turn off your video and mute your audio. You may post your question or queries to the chat box, maybe privately with Satish, or otherwise to everyone, especially on questions. He's compiling it end of the session. We'll have a discussion on that particular Q&A part. Before going to the topic, just I want to listen some stories of yours. So that is this is a part which I am looking out your name, company working for, and part in this particular webinar. Any other input which you want to share? Maybe the rules which we can say that is you can do it via chat box, either by private or to everyone, or that's around 60 seconds. So I think I'm audible. You can able to see my screen also.
Gopi, carry on.
Thank you so much. So this is 60 seconds, which is, you can start giving it in the chat box. Maybe I will, in the meantime, for counting 60 minutes, I'm giving it 60-minute motivational video right now.
You all have vision in life of what you want to be, to become. You all are by God with some or the other talent. We just need to identify that, and then from an uncut, unpolished diamond to become a polished, priceless diamond. It is a process, it's a journey where the path won't be easy. Sometimes when you're trying to do certain things, there might be obstacles. Don't give up, don't find shortcuts. I think it's important to follow the right path always. And in tough times, tough men last. So I'm very, very confident that if you follow the right things in life, you will be able to achieve your dreams.
Yeah, thank you so much on this viewing this particular motivational 60-second video. Again, I'm going back to the original slide. Yeah, hope you can see my screen now, all of you.
Yes, sir.
Yeah, thank you, Silva. Yeah, coming to the stories to say, basically who I am. That's a one which is I want to share with you guys. Basically, my name is S.R. Gopi. Friends call me as Gopi. Don't ask me how your boss and my wife calls me. So that is a secret. That is a role. What I'm doing right now with the Control Technique is a zone director for South Asia. Working from Pune, it's a western part of India. So overall experience, 23 years in sales, business development, and marketing. When I started my career, I started as a air ammonia cooling unit selling manager. Then I moved from air conditioning to now VSDs. So I am here today, or what is it for me and you? That is a question which we asked before starting, that I'm asking right now. So I can able to gain some knowledge from you all with your experience in your field. And even I'm looking out the chat box. I'm seeing a lot of mixture of people which is having a lot of experience, which we can able to learn each other. share tiny bit of my working experience knowledge, especially on the technical, especially on HVAC and refrigeration and the VSDs. Finally, learn to know together how we can save money and earn money by putting a VFD in HVAC. Today's topic, which is we are talking about VSDs, is going to reduce the energy consumption and increase the life of refrigeration system. So what do you mean by reduce energy consumption in terms which is we are saving energy and saving money? That's it goes. If you save money, that you are earning money. You know, that's indirectly we are earning money here. So today's session outline is going like this is a store for today, like HVAC and refrigeration introduction and its principle and its applications. Then goes into the compressor. Basically, that's a heart of the system. It's a type of compressor which we are going a little bit detail about. That's a type of compressor like screw, and centrifugal, and as how we are going to modulate this particular compressor. Then second part, it is a pumps. Third on the fan and AHUs, which we are going to talk about on the case studies rather than going in detail about the principle and types. And finally, this is a crux of the today's meeting and I mean to say my interesting topic also, that is energy saving and increased life of refrigerations. And we can go with what we as a Nidec control technique do that we are having today for the session. Coming to HVAC and refrigeration, that is, I think everyone, we are at home right now with the COVID-19 situation. Maybe you can have a look in around, you will find a refrigerator. That is one of the refrigeration system which is available day by day. And are we utilizing this particular refrigeration system in efficient way? That's a big question again. Why? Because if I take about mine, you know, I bought this 2006 when I got married. Still, it is working on it. But after that, a lot of development happening on the refrigeration system. So that efficient way of doing the refrigeration system, still it is we are lack, or otherwise we are behind with new technology. Coming to the description on this particular HVAC, like what it is heating, which is do, especially in cold condition, like in India, we talk about in Kashmir and Ooty. These are the places sometimes you need to have a heating pot. So that is used to heat private house or public building at the cold climate. That is what we are talking about on the heating. What are the components used in the heating? When you see here on the left side on the this is a heating pot. We'll find it certain components like boilers. It heats water in closed system, which is the one part where you can find it on the boilers, which is the deep portion, which is here is a boiler, and pumps, which is circulates the water in the closed system, and radiators. It's basically mounted on the walls. It's in the like a panel through which the heat get passed onto the house or the building, and the hot water cylinder, which stores hot water for the showers and the baths. When coming to the air ventilating, which is nothing but ventilation system, which is the process of changing or replacing air in any space to control the temperature, which is to remove moisture, to control the humidity, and remove those odors, heat, dust, and smoke, and remove airborne bacteria. This is all we talk about ventilating. So what are the components on the ventilating part? Like, we have a supply duct, we have a fan compartment, we have a vibration isolator, and the heating and cooling coils, and the filter compartment, and the return fresh air duct. This is all we are talking about on the component. When coming to the air conditioning, it's more or less this is what we use in the window AC, which is we have it at most of the houses, even the split ACs. So we come to the application part. Like this is a part which is again used for the thermal comfort reason, which is the components like compressor, condenser, and the expansion wall, even the evaporator and the refrigerant. When you coming to the refrigeration part, this more or less it's air conditioning only. Only the difference between the air conditioning and refrigeration. Air conditioning, we are into plus degree temperature for the comfort application. When go to the refrigerations, we are having a lower temperature application. Coming to this working principle of HVAC, that's how the cooling or refrigeration is happening through that system. We have types of refrigeration. One, we can do melting ice. In the olden days, people used to have ice melting. In that, we can get refrigeration part. Another one is supplying dry ice. And another second type of refrigeration is cyclic refrigeration, where we can do vapor cycle, which is vapor compression cycle, and the vapor absorption cycle, and the gas cycle. And third one is thermoelectric refrigeration. Fourth one is magnetic refrigeration. Mostly out of this, all the types, the vapor compression cycle is mostly used and widely used because of its mature technology and as well as relative inexpensive method of doing a refrigeration. That looks like, we can see here, this is a compressor and the blower motor, which is in again the evaporator, which is used for the even the split AC or air conditioning. We can find it in the evaporator section. Then we have expansion valve and the condenser and the receiver and dryer. When this is basically on the component part, when come to the chart, how it looks like, the entropy part and the y-axis, we can see temperature. This is temperature entropy diagram. We can able to know how the principle works on the refrigeration. First, we can see that point number 1, the refrigerant enters the compressor as a saturated. 2, the saturated vapor is isentropical, that acts as a superheated vapor. And 2 to 3, the superheated vapor travels through the part of the condenser which removes the superheated by cooling the vapor. It's not completely get into the vapor become a liquid. It's only the partially we are doing it. We are removing a superheated vapor. Then from 3 to 4, which is vapor, again travels to condenser, which is we are taking it. Condensation is in process, especially on the constant pressure, we'll get the saturated liquid. Then 4 to 5, saturated liquid refrigerant passes through the expansion valve, which is undergoes an abrupt decrease of pressure, which we can see that in thermodynamics. When I'm reducing the pressure, I'm decreasing the pressure immediately. What will happen? The temperature drops at very low level. That's what's happening in the thermal expansion valve. Coming to the 5 and 1, which is again, it goes into the evaporator mode, where we are getting that cold or air, warm air through that. It's warm air passing on to the evaporator. This is on the principal part. And coming to the little more detail on the terminology, what we are using it in vapor compression cycle. Why I'm using this terminology? Because when I'm using it VSD context, this all get affected. Suppose if we are talking about tonnage of refrigeration, which is in the while specification of any air conditioning, it always goes with the tonnage of refrigeration. And second one is on the coefficient of performance. When I'm going with modulating my compressor, modulating my evaporator fan or condenser fan, this all the terminology get moved plus or minuses. That's why I'm showing here. So that COP and EER, basically it's more or less same, only the numerator and the denominator, which is, this is a ratio of cooling and the heating capacity versus on the power consumption, on the COP part. When EER, again, we make it a little more seasoned one, that is called seasonal energy efficiency ratio, which is this is a EER basically on the system design calculation, when seasonal energy efficient ratio basically on the based on the climate condition, like that climate varies day by day, so that system doesn't work at the rated condition all the time. So this is on the SEER. One of the technologies that superheat and subcooling, because whenever I'm reducing certain temperature on my condensing and the subcooling part, again, it does affect my overall efficiency, overall energy consumption. So that's why I'm putting here on the terminology part. Coming to the HVAC applications, like we have again subdivided in four. That is, one, it is on the air conditioning, and second is on the commercial refrigeration. Third one is on the industrial refrigeration. Fourth, the transportation and the automotive refrigeration. If I looked at the air conditioning part, based on the system layout, we can have this many types, like chiller, split type, self-contained, rooftop. When go to the functionality type, you can have it heat pump and the cool only. When go to the industry, we can have it for the food processing unit, even for the banana ripening, or otherwise go to the grape mango ripening. This all into the even the cold storage of onion, potato. So this all into the fruit. Go to the chemical and process industry, especially on the medical part, like formulation unit. They need to have maintain. We need to maintain some humidity and temperature. This is comes and again into the process and chemical industries. Even the certain chemical industry also need to have a refrigeration part. When coming to the commercial refrigeration, we can see ice machines, display cases, and freezers, a little supermarket, process chillers, all goes into this particular application. And finally, on the transportation and the automotive refrigeration, we are using it for the transportation refrigeration. Even the car which we are driving, again, this AC, it's run by air conditioning. So this is all about on the introduction on the HVAC and refrigeration part. Before moving to the main part of compressor and the pumps, just I want to show what as a control technique, need a control technique doing for this particular industry. Maybe I can show it little video on this. And this is a one again, which is a little insight on this. Maybe the HVAC, again, I can able to see the combination of heat exchangers and the medium to transfer the heat. And third one is the component or the equipment which used to make this particular exchange of the heat. Like anything you can see, this cooling coil is one type of heat exchanger. This is a fin type. When going to the evaporator, this is another one. It is a shell and tube heat exchanger. Condenser is again shell and tube heat exchanger. Cooling tower, it is one type of heat exchanger. These all are heat exchangers. And I'm coming to the medium, which is air is one medium, water is another one medium, again, and air is here. If I see out of this, three closed loop, like water is having this particular loop is a closed loop, refrigerant is having closed loop, again is the water is having closed loop, this is air is having a open loop part. This is medium on the heat exchanger. And coming to the fan, which is run by motor, this is maybe axial or centrifugal one. When coming to the pump, this is one another motor is run by pump is run by motor. Second, third one is on the compressor. Again, is run by motor. Everywhere the energy consumed. Like condenser pump, this is again the run by motor. Like cooling tower fans, again the motor. So that's why I said we have a heat exchanger and medium to exchange the heat and the equipment to run the make this happen. So before going to the compressor and the pump, I want to share with you all what as a control technique we do for this particular industry. Can you able to see my screen? Hello?
We can see your screen.
No, we can't see.
See your screen, Gopi.
Janet, can you able to see my screen, Janet?
It's gray. It's a gray screen.
Just I'm holding. I'm coming there.
Gopi, it's gray here as well.
Yeah, I'm coming, Ramesh. Yeah. Now it is. So if we see here, like in the HVAC, what we are into, we can see that we can go with control technique as a energy saving estimator. Whenever you have a air conditioning, it's existing air conditioning, when you want to see how much energy going to save by putting a VSDs. Anyway, we have finally I will show that some of the case studies what we did in leading customers in India. So this is one, it is available in the website, and we can able to see how it's what is the square law flexing, and the dynamic V by F mode. This is one another point which is most of the competitors not having it. This is a control technique what we have it in this HVAC part. So this is one I want to show. Another one, yeah, thank you so much on this. I think this is what is available on with our website. Just I want to share with you all. Yeah. So coming to the compressor, it's a main component or otherwise main equipment of the air conditioning system. This is what is compressor all about. This is basically a vapor pump, which is not a liquid. And this is we are compressing it. That's what we are doing it on the compressor. How it's again divided into or classified into positive displacement pump or a compressor and the dynamic compressor. This is again we can classify it like reciprocating, rotary, single acting goes on like this, and the centrifugal and axial compressor. So we are going to talk about four types of compressor. One is on the reciprocating compressor. It's also called as a piston type, mainly used in the air, process air and refrigeration. It goes from 0.5 HP to 500 HP, which is higher efficiency at pot load, and it's again types hermetic and semi-hermetic and open. Like fully hermetical one, which is used in the normal refrigerator and the household refrigeration system. When I come into the semi-hermetical part, maybe I can give a little more detail here on this hermetical and the semi-hermetical and the open type. Basically, this is a bill less than 15 HP, which is used in the fully hermetical one, and semi-hermetical used on the little above. but is not used in the cannot be used for the ammonia plant because it's a refrigerant attacks motor winding. So this is, we may not use it for the ammonia part. So open with the ammonia, it's run by V belt. So what's the difference between hermetic and semi-hermetic? Hermetic, we can able to we may not able to dismantle it or disassemble it, but semi-hermetic we can able to do it. When you coming to the scroll compressor, this is one another type, which is used in the water chiller and packaged air conditioning and rooftop units. And this is basically the typical HP. It starts from 1.5 HP to 60 HP. It looks like this. This is a base, and again we have a stationary scroll, and we have a orbital scroll, which is, we can find here, the white side is a stationary one and the gray one is orbital. This is the compression process, a continuous one. How it looks like, if you see here, that's a section one, it's happening on the first orbit, second goes in compression, will take place on the second orbit, third one it goes it on the discharge, it's the third orbit. Coming to the two more types, rotary screw compressor and the centrifugal compressor. This is a rotary type, rotary screw type. So again, this is stage one. We have 5 stages on how the compression is taken place. What is the range? It goes from 20 to 500 HP on the air compression, goes into the refrigeration 30 to 30 HP. And the when coming to the working principle, this is basically the A. It looks like how it is, the compression, the section is happening. After that, it does, section goes in the little beginning, starting in for the compression, second goes into the full compression, and coming into the discharge part. When coming to the centrifugal part, it does goes a little higher on the HP range, which is goes up to 20,000 horsepower from 100 horsepower. And this is a one which is used for the low cost for large consumers, and we can able to do it around 2 lakh CFM for 5,000 PSI. This is a section, and this is a discharge. We have impellers. Then what is the other objectives and the details on this compressor part on the types. When you coming to the modulation method, I'm not going to detail about this completely. Maybe we are sharing this input. I will go a little bit on some cases like, multi-stage compressor system, wherever we have a compressor. Suppose 40 HP compressor, if I am in demand, I can able to use it for 10 HP compressor. Or, that is a system which I can use it. Either I can put it all for an stop. When I need it only one, I can run it one compressor. It goes on like this. It's having certain advantages and disadvantages. Second modulation, I can do it through hot gas bypass, which is having certain advantages, which is nothing but what are the gas which is coming out of the discharge, we can bypass back to again back to the compressor. That is one another part. When coming to the inverter, we are doing the refrigerant flow. We are modulating the refrigerant flow by varying the speed of the compressor. This is one another way of doing a model compressor, having certain advantages and disadvantages part. Coming to the screw compressor, we can able to modulate. These are the methods like on-off control. Whenever we need it, we can put it on. Whenever we don't need it, we can put it off. So how the power consumption, goes based on the capacity and the power consumption. And load, no load control. It is nothing but, based on the capacity demand, we can able to go with controlling that compressor. Third one is on the slide wall. This is one another method of doing modulation on the screw compressor on the slide wall portion. Sorry, I don't know what is, we cannot control. Fourth one is on the throttle wall, which is the way we can do it. When I coming to the VSD, this latest one. Atul, I otherwise requesting to unearth the shared content. I don't know what it is, Atul. Okay. So this is a VSD control. Basically, this is a way we can able to modulate the screw compressor also, which is, you can see here on the complete comparison with the power and the capacity. This is the ideal situation how the energy consumption graph is supposed to be. This is a VST, variable speed drive control, how we are doing it on the screw compressor, and this is slide wall method. We can able to see that, how much saving of energy we can do putting a VSD on the compressor front. Out of this, all the component compressor consume a lot of energy, so that's why we are, focusing on this particular region. Coming to the another one, which is going with the centrifugal compressor modulation method, which is we have IGV, inlet guided range method. We can have how that it's nothing but we can able to modulate the suction capacity, or otherwise that we can able to modulate on the input side. That is a way we can able to save certain energy or modulate the capacity. Another one is on the variable diffuser control, which is one another way we can do it on the discharge side, which is we can able to find out on this. Coming to the uh, VSD portion, which is we can able to see here on the what are the advantages, especially on the VSD, which we have. I think it's already Satya was one of the session. He's talked about what is the VFD, and he explained a little bit on the energy saving, especially on the HVAC context. I will come back on the VSD. What are the application? How we are going to save energy on this. So right now I'm again going back to our expert, Mr. Srinivas. Srinivas, are you there? Maybe I can unmute you. Let him have word about our product. Anna, can you able to unmute Mr. Srinivas? Yeah, Srinivas. Good morning. Maybe I can brief about Mr. Srinivas. He is 28 years of experience in the drives and BMS. He is exclusive HVAC partner for India, who's situated in southern part of India. Especially, he's taking care of three regions, three areas: Bangalore, Chennai, and Hyderabad. So he is associated with control technique for more than 2 decades. So I'm please, Srinivas, I'm floor is for you now.
Thank you very much, Gopi, for introducing me. And it's a nice talk that you're given on the HVAC application till now. I'm from Virgo Technologies. I got a 5 minutes time to go through the slide, so I'll not take much of your time in detail going through these points. Okay, we are partner for Control Technique, as mentioned Gopi. Now it's going to be around 3 decades now for next 1 year. Then we are giving a complete solution for HVAC need, for the base building application. So that includes the variable speed drive from Control Techniques. Then we are also giving a BTU meter that is used for measuring the energy of the chilled water that has been produced by the chillers of the central plant. Then we are also controlling the air volume, which is given to the air conditioned rooms by way of using variable air volume controllers. So then we have the building automation system, which controls everything that is required to maintain the set temperatures in that particular building. So if you look at these 4 products, everything goes one after the other. So the VFDs, which runs the motor of air handling unit. Then once it runs, when there is a load, the BT meter measures the energy produced by the chilled water. Then once that is done, when the air is thrown into the cabin to maintain the comfort temperature, the variable air volume, that's called VAVs, will control the air thrown into the room based on the temperatures. So in turn, that modulates my VFD. So that is another product. Then finally, all 3 gets connected to the building management system and controlled centrally from the BMS. Both controlled and monitored here. So if you look at this, we have 1-point solution for all these needs. And we are one among the few in India to give the complete solution when it comes to HVAC need. Now, we have the complete design solution in-house. We have the project team, and we have the after-sales service for this. Now I will straight away go to the product, that is C200, which we have been selling. Earlier it was, we began with a model called Commander SC earlier days in 90s, then CD, SC, CDE, multiple models we have moved on. Then the latest one is Commander C200, which is slightly modern version of M200. Okay. Now in HVAC, basically, as far the VFDs are concerned, whatever has been there in the market for a commercial building or a pharma anywhere, it is more of a speed control to control the either a temperature or the volume of the air. To achieve this, we only do a speed control of the motor. However, we got quite a lot of other parameters that need to be monitored or need to be integrated to perform the subsequent functions, as I mentioned to you in the other next stages. Now, for the HVAC applications, with all our experience, we have gone through some of the key parameters that is required, which is there in our C200 series of drive from Nidec. Considering the volume of the drives that goes into a building, let's say we are talking of a 20-floor building that may have, let's say each floor may have two wings. That means two VFDs per floor. Then 20, we are talking 40 VFDs in one particular network. Let's say example 11 kilowatt, we are talking nearly around 440 kilowatt load from the VFD. So one of the most important point that we need to look at is the harmonics that has been generated by the drives. So while as per IEEE, we have got multiple standards that we need to follow. However, there has been some guideline that a particular VFD need to have the built-in DC reactor. It is only to minimize the mains borne harmonics, not completely remove it. It just minimizes the mains borne harmonic. That is one which is a part of C200 from 5.5 kilowatt and above. We have in that as a standard inbuilt. Then EMC compliance, which is one of the key element in the VFD, because this all we use IGBTs. There are noises that is generated by the drive, and it may interfere with a DDC controller or a communication cable that is getting connected to the ELV products used in this particular building. Okay, so we have a certain compliance which we have to follow in HVAC. Either we call it as a C2 filter or a C3 filter, which meets certain EN norms, the European guidelines. So we have that with C200 drives. Now, this particular list, what you see on the screen, is basically done keeping in mind the need of the consultant, the customer, and the BMS vendor. The BMS vendor can be anybody. We need to just integrate with them. Okay. Sometimes we have to work as a standalone product. So there's no building automation system. Then we use our onboard PLC logic that is available in C200, where we create some functional blocks and execute the jobs for each user. Then we have got BMS protocol. Yes, we have Modbus in C200 and both Modbus and BACnet in H300 models. Okay, now this is most important. The success of your product lies in the implementation of this particular building automation integration. Because this is all distributed, all the VFDs, everything need to be integrated right onto the building BMS software to monitor from the central location. Is something similar to the SCADA on the machineries that you do. But the difference between the machinery integration and the BMS integration is huge. Here in the machinery integration, all your drives are located inside one panel or multiple panels located in the same place. But in HVAC, it's distributed in multiple floors. You take each floor 3-meter height. It has to go through multiple routines. So your success lies in proper implementation of this particular cabling. Okay, and integrating with the BMS. Rest all standard feature of the drive which will automatically work. Then the demand in the market is the alphanumeric display for the maintenance person to view the parameters and program it or navigate it accordingly. Sometimes we also use the PID controllers. One is the process PID controllers, of course. One for controlling the chilled water valve that is supplying the chilled water to the AHUs. So either the building automation will do that activity and just gives a command to the drive to run at a particular speed, or within the VFDs used by use of two PIDs, one for the speed control, other is for the valve control. So we can achieve the functionality. Now, the whole purpose of the VFD being used in this application is for energy saving, as mentioned by Gopi. So we have runtime clock in that KWH meter is there in the drive. Then we also got some of the sequential logic controller. So probably, this is all useful when you use the real-time calendar in the drive as an option. Then,
Sure. Yeah.
okay,
Thank you so
I think
much.
then I'll go through quickly 5-6 points. Repairs Gopi mentioned other time is required. Sleep and wake up function. Okay. PCB conformal coding is one of the key point that you have to consider because of condensation factor that is in the AHUs. Then filter change for AHUs. See, this what you have to look at is the wording. Filter change for AHUs. Okay, the functionality is already built in the drive, but only you have to rename it in a right way required for HVAC applications. So these are some of the few big points that I could be able to give you. So anytime you can contact me through Gopi if you need further inputs on this.
So thank you so much for your input, Chair. Thank you so much. Maybe we can unmute you.
Yep.
This is one of the expert. What he's talk about control technique drives. He's associated with for 3 decades with CT, and he's selling not only a building sector. He's selling in even the pharma sector, like in India, many places. Coming to the next component, that is pumps, which is one another big part of the equipment, which is we can see little formulas. Basically, I want to give a little thrust on the affinity laws. Basically, the flow directly proportional to the speed of the pump or speed of the motor, and head directly square of speed, and power is square of the cube of the speed. This is a main one. When coming to the head, how we are how we can able to measure it basically on the head, which is the dynamic head and the static head. We can able to see here that finally on the head versus flow, this is the one which we need to focus a little more. Like we can see here, this is a pump curve. When I'm talking about here, this is a head maximum, and but there's a Q0, the Q minimum. Here we are talking about Q maximum and the head 0 minimum. When I'm designing the pump, this is a nominal or other head pump. This is a designed flow or otherwise meter per hour on the pump part. Otherwise, when I'm designing the pump, this is a flow and this is head which I'm designing it. The system curves look like this and the pump curve look like this. When meeting together, it is called pump duty point. When I coming to the read the curves, basically on this particular curve, we can see here on the head one side, and again this is the efficiency on this side, and this is a duty point, which is we can able to see. This is a flow, and this is a power consumed on particular RPM or particular speed, and this is again the particular RPM. What is a head? We can able to get to know. Suppose if I take it one case, I'm talking about the efficiency of pump is 85%. The head is at that particular time, the head is 25 meters head delivered, 1 kilowatt, and the flow delivered is 300 liter per second. So this is how we can able to read the pump curve. How we can able to modulate pumps? So we can, is it first question, are we going to modulate? Is it required? Yes. Why? Because the midnight we are using that for 100 ml per second for the glass of water, maybe for freshen up ourselves. When I coming to the shower, which is 1 liter per second, which is used in the afternoon, maybe if you're going for gardening, around 10 liter per second. So in that case, the variation of the load always varies. So then that's why we need to control the flow. How we can able to do it? Maybe one another point I want to share on the pumps. Whenever I need to go more volume, what I need to do, I need to go with the pumps in parallel. Suppose the pump one deliver 100 per hour, I need to have a 200 meter cube per hour. I need to go with a parallel pump like this. I will get more volume here. When I need a head, I need to go with the connection of series, which is the pump one delivered maybe the H1, which is the maybe 10 meter head. Second one goes to another 10, maybe put together a 20 meter head. The flow will not be here. It is not much addition when I coming to the series and the parallel. How we can able to do that method of controlling the pump and the power consumption here pot? We can do the throttling the wall by outlet when I'm coming that coming out of the pump. So what we are doing it here, this is, as I mentioned already, this is a system curve. This is again the pump curve. When I'm getting it Q1, which is the full opening wall, then I'm throttling it by I'm closing it, I'm getting it the flow reduced. What I'm doing it, I'm not changing anything on the pump curve. I'm changing my system curve from here to here. So what are the saving? I'm getting it here on the saving when I go with the power, like you can find it here. This is a saving what I'm getting it here on this part. When I'm coming to the next method is on off mode. When I'm doing it, this is the on position. When I'm doing it, so I'm keeping it the same, but I'm not having a much energy saving by doing this. When I'm third one, we are going with the bypass arrangement. Whatever the output of the water which is coming discharge, we can bypass it back. So what we are doing it here, instead of here we can see that the system curve goes up, here the system curve is coming down. So this is again, we are not disturbing anything on the pump curve, we are disturbing on the system curve. So that again, we have a little bit saving, not much saving. And coming to the VSD mode, variable speed control mode, what we are doing, that pump curve remains same, we are system curve remains same, the pump curve we are reducing it back based on the demand. So that is why we will have a lot of saving here. This is only the energy consumption when I'm doing with the demand of Q2. So what it mean by when I having 10 liters of bucket, which I can carry 10 liters of water, when I need only 5 liters of water, there is no need to lift the 10 liters of bucket, that volume of bucket, which we can able to use it with the 5 liters of bucket. So this is one another concept, which is especially control technique we do as it, that is multi-pump SI duty assistant, which is we have one pump we can connect, one VFD we can connect maximum up to 4 pump. This is a fixed rotation. Whenever I have 4 pump, there is no need to have it 4 VFD. If it is a demand is fixed, only the varies on the final pump. So this is one way of doing it. Another one is the flexible duty, where I can able to rotate the duty. Here we can able to do only with the 3 pumps, not 4 pumps here. This is one another facility which is available with CT range of product. Coming to the before final slide. So I think you're not getting my audio. Hello.
Audio copy.
You are getting it? Okay, thank you. Because someone writing it's not getting audio, that's why I'm asking. Fine. So if I talk about that's one of the case study which is we did with the big corporate customer in India. This is a way we did for the fan. Actually, just we can able to. This is a value engineering. We talk about value engineering. We assisted to do that. They have nearly about 150 AHUs without having a VFD, which was running. They used to consume a lot of energy, but we went and suggested them to do this particular value engineering report. So this is a way we given the report to them. And you can see this many VFDs we installed in the system. This is on the air handling unit. So how it goes like this, what is centrifugal pump, how it is, what are the components here, how the VFDs works, and goes on this. and little bit on the what are the starting method on the motor, like DOL, star delta, soft starter, and frequency converter, how the voltage curve looks like, how the current curves look like, how the torque characteristics look like, what are the features on this. So this everything we explain, and given this particular value engineering report to this particular management, so that in that case they can easily approve it. So this is how that another concept of affinity laws, which we are talking about on the flow directly proportional to the speed, and power directly proportional cube of speed here. This is which is we can able to see on this, and what are the way we can do that air conditioning control on this. And we have energy calculator, as I said, energy saving calculator in the website. We can you can download it by giving getting it certain approval from our factory. So you can also do this particular exercise at your end. If you need by, we can assist you to do this. So finally, we can get to know what is a payback calculation here. It is less than around 1 year. That is time period is expected time period is less than around 1 year. That was the one what we made it for them. Coming to the one another exercise on this. Okay. Yeah. Okay, this is one another area where we did on this. I think you're not able to see my screen now. I'll open it once again. I'll share it. Okay, sharing this. Yeah. So left out 8 more minutes. We can close it a little fast here. Like this is one of the case we did with another one of the end user, which is based out in near south, where what is a cooling tower fan, what are the finding description, what is the proposal, what are the panel requirement here, and evaporators, and evaporator pump. This is all it is did with personally, because I'm, as I said, this is an interesting topic for myself. So which is we are talking about on how is saving estimated, putting about on the annual power cost saving, what is the price, and going with actual reading after installation on the VFD. This is one exercise what we did. The one I want to share with you on this energy saving tool. Okay, stop sharing again. Share it back. Share area. See, this is one we can do that even if you give us that input, what we can do, one of the case, like maybe we can go with the fan or pump, which is there. I can say if you're running a pump of 100 HP, that percentage of efficiency, maybe I can keep it around 85%. That load factor, we are using it maybe 70, or we can even take it 90. So this is, you are running about maybe 6,000 hours per year. Coming to this, what are the method already you are using it? Basically on the, suppose I'm using it on the IGB, on the inlet gate vent method. I'm clicking here. This is a VSD, what you are going to propose right now. So we can able to find out how much is the saving, annual saving, and what does a curve looks like here on the comparison of this. This is on the proposed one. This is on the IGB one, inlet gated well. Any other method, like constant volume method, you can click here, then you can saving automatically get increases. Then again you can see the curve how it looks like. The same way we can go with the pump analysis also, like we can do all the part, like non-constant pump and the VSD. Maybe if the question may arise as I am using it VSD to VSD, what will happen? That's more or less the same, nothing will change. There's a VSD part, already I'm having exiting also VSD, no saving here. So this is only certain case stories on the fans. I don't want to get into the fan a little detail on the basics. So that's why I shared on the case studies on the fan part. So coming back to again on the final slides, basically here, whatever the energy we are saving it, it's, we are, earning the money, we are saving that money. So like, as I said, what is VFD? First question. Second, why is, I need a VFD? Second, third is where I can use the VFD. So that way we can see here, like complete air conditioning system consumption based on the compressor, pumps, and the fans, overall kilowatt per tonnage, which is, sum of the all above kilowatt per and tonnage of refrigeration. Nothing but, how much energy consumed and how much output I am giving it out of this compressor. So you can see here on this again, compressor is a constant torque one, and second one is on the fan, which is the evaporator fan. Third one is on the condenser fan. This is again the pump. This small, air conditioning system, which is nothing but I can say window AC or split AC. When you'll have a chilled water pump, that is again secondary, primary, cooling tower, fan, cooling tower, pump. So many things it's coming to this big system. Just I want to show the small one. So whatever the saving we are making on the energy, which is we are converted into the energy cost, it's become a cost saving or otherwise money what we earned out of putting a VSDs. So this is in a typical payback period. It's less than 18 months. What my experience says in this particular field. So this is all about my from my end to and on this what we do, that is an overview. As I said, some of the slide you can see drive specialist since 1973. This drives technology itself a young technology, not like a rotating equipment technology. It's a 50 years old technology. We are the pioneer on this. It started in the 1973. You can see here we have a soft starter, we have a servo motor, we have a drives up to 2.8 megawatt, all. So you can find it even the website. Otherwise, you can connect with our sales manager, nearest sales manager, they can help you out. So finally, my question and answered. So maybe Satish, you can unmute yourself, or otherwise Anna, you can unmute Satish. Help me out with the questions on the chat box, Satish.
Thank you, Gopi.
Yeah. Do you have any question on the chat box? Because it's a lot of chat messages in this. I'm not able to locate which one is I need to reply back, or because mostly yes, no.
I'm not able to share my screen, Gopi, but questions are very few. Only one question. Mr. Rahul Karim, what is the maximum energy saving for screw type at air compressor by CT inverters?
That is depends upon, I think MK around 1130. Yeah, that's it depends upon load condition, sir. Maybe what we can do, you can help me out with a little input on this. Then what we can do, we will help you out that particular energy saving calculation to you. Again, compressor, we never used to go for retrofit or otherwise. It's part of the system, so we always go with the OEM manufacturer, especially on the compressor.
Okay, another question. Are we going to get any participation certificate and the recording link of this meeting? This is from Star Tech.
Yeah, sure. That is happening. We will give it no worries on that. Okay. Thank you, Satish. Anything else?
Yeah, these are two questions which we have in the chat.
Yeah, one question I seen it somewhere on the what is the difference between VSD and VFD. I think wherever you are finding VSD, it means common for both. I mean to say three-phase, otherwise AC drive and DC drive. That is we call it a speed variation. When you go with VFD, means only on the AC drive. So whenever you have a frequency which is talk about AC, whenever you have a VSD, it's common for both AC and DC. Hope I answered your questions. Big thank you to all of you guys, and sparing with me for 1 hour. Thank you so much, and stay safe, stay well, and stay home. Thank you. Yeah, I think Mukesh, are you there? Mukesh, I think you have some question. Mukesh. Yeah, Mukesh, you talk about what is energy saving on the soft starter. I think energy saving on the soft starter. First of all, you need to understand why VFD is used in the any application. That is for three reasons. One is on the first of all, interest current saving or otherwise capex saving. Second is on the energy saving, and third is on the automation part. Especially on when you go with a soft starter, which basically this particular part is used for only interest current saving, not on the energy saving part. Maybe you can use it for the bigger kilowatt rating, Mukesh. And someone is asking on the VST, please explain variable speed drives. I think, I don't know. Screw compressors and same based on the type of motor, induction motor, and PLC component. Okay.